so far. So on the sake of timekeeping, I shall start now. I do hope that everybody can hear and see me. Hope so. Joe, you let me know if it's okay. By default, you are all muted. So just keep that in mind if you want to make an intervention. So this is the AIRS Observation Australia Whole of Community meeting. I am Graciela Metternich, a professor of environmental geography at the University of New South Wales in Sydney, and I am a member of the steering committee of the AIRS Observation Australia. So Stuart has decided that we all share our load and we all have turns in sharing this meeting. So it's my pleasure to be leading this morning's meeting. We will start at 11 and we must finish by 12:30. So I will try to keep all the interventions on time and try not to be rude, but just reminding if someone goes over time, you will get a kindly reminder from my side, so we all can finish at 12:30, and we have the time for the presentations by Adrian Fisher and our two invited panelists, Dr. Martha Jebra from ANU and Arcul Lucier from the University of Tasmania. Just a quick reminder on the agenda of this morning, if it's working. We will have some information on current status and engagement, and we will have then the update of Earth Observation Australia, followed by this interactive presentation to then close at 12:30. So I would like to start this morning then with the first presentation that will be on the industry profile by Trident Space, Nick Karangelen and Eddie Cato. And for this presentation, I think I need to share the screen with people in DC, right, Joe?
Sorry, Graciela, that's correct.
Yeah, okay. So we can, so for this, for current status and engagement, we will have the industry profile by Trident, then the Geo Week 2019, Joe Andrews from Australian Space Agency will give us some update. Stuart on the National Collaborative Research Infrastructure Strategy. Then we will have an intervention by Lachlan McKean on the Australian Ocean Optics Conference feed. So let's start with the second part of this morning webinar. And may I then invite Trident to share, to pass on the screen to them. Okay, Joe, you will need to tell me.
Good morning.
Hi,
good morning.
Good morning. Okay, Nick, stop sharing and I need to pass on. Okay, there you go. I can see you and I can see Eddie.
Okay.
Joe and everybody else, can you see the screen? I will put myself on mute then.
Okay, Ken.
I think we're supposed to upload the show the presentation, I believe, right?
You'll be able to share your screen if you scroll your cursor to the bottom of the screen. You'll see a share icon. If you click on share, and you'll be able to share your screen.
You know, I was just about to do that, and the Zoom meeting disappeared. I don't see it.
I think, Nick, you see share in the bottom of the screen.
The Zoom. Oh, here we go. Let's see, is this it? There it is. Jeez, it just disappeared on me. There we go. Let's see.
Yeah, you have to sort of when you scroll over with your cursor, it will appear and disappear. Yeah.
Okay, so there. I think. Can you see it now? Can you see my presentation?
No.
I'm clicking share and
Share, and then it will ask you to select a window or an application.
right. Oh, there we go. Share at the bottom of that window.
There we go.
All right. Can you all
Excellent.
see?
Yep, thank you.
Now, let's see if I can make it full screen without. Did that work?
Perfect.
All right. Okay. Thank you all for the invitation. Really, Eddie and I really appreciate the opportunity to talk to you here from across the other side of the globe. I have quite a few slides. I'm going to go quickly. I encourage you to interrupt me if there's something that you want to ask, or please follow up with an email, and we'll be glad to answer your questions. Of course, in the next 15 minutes, I won't be able to cover everything in detail, but I think we can give you a picture of what we're up to. So my first slide, we're Trident Systems is a little innovation company that has developed a satellite transceiver for RF, and Trident Space is a spin out from that company, and we are going to commercialize that technology and build what we believe will be the first highly affordable, high-resolution SAR imaging satellite. We'll be able to get SAR images down to as fine as 0.3 meter. We believe 1 meter resolution images will be our workhorse resolution, because we think that's the best to collect the kind of information we hope to collect. And we expect to be able to sell that data for less than $10 a square kilometer for a new collection. And the reason we think we believe we can do this for such low cost is because we're leveraging this new high performance space radar technology that's coming out of Trident Systems. We have the exclusive license to commercialize that. And of course, we'll be using the affordable new space technologies for small satellites that everyone is talking about these days. Ultimately, our goal is to not just to provide SAR imagery in the sort of the style of the current providers that are commercial, but to really, with the low cost and what we believe is an elastic market, create new markets for business information, not just governments, but also business, using these SAR imaging and the emerging data analytics to extract information from those images, because really no one wants to look at a SAR image except maybe for a SAR analyst. Business people want information, and that's what we hope to deliver. Of course, we also see continuing government use of SAR for intelligence and geopolitical purposes, and also non-government organizations that are trying to stop illegal fishing and illegal foresting and other things that we believe we can support. So this next slide gives you a quick summary of where we came from. This was originally a UAV system for a very small UAV, small radar that NASA latched onto. They loved it, and they said, can you help us build one for space? And so we had about an 18-month project with NASA to build a space-qualified version of this payload. And it's scheduled for a NASA mission in 2026 or so. You know, it takes NASA a while to get to their completed missions. But we delivered the first engineering development model in January 2 years ago. And this first space version, the first flight version of the transceiver was launched in March of 2019 and is currently operating in orbit for a U.S. DoD mission. So we expect to offer 3 principal products. As I said before, we think the number one product is information. These are going to be periodic reports that are tailored to specific needs of government or industry, and extract information from SAR images to provide these reports. We also imagine custom periodic reports, perhaps for an insurance company who's interested in a particular area for hurricane damage, or other types of industries that would like to have their own periodic reports. Of course, we'll sell SAR imagery as a part of the current ecosystem that uses SAR. Again, we'll be offering SAR at rock bottom prices, less than 10 times cheaper than TerraSAR X for the same 1 meter resolution type imagery. And you'll be able to order ad hoc on-demand collection of individual images or collections of images as we offer. The final thing we'll offer is a timeshare. You could buy an entire orbit or segments of an orbit. We've already had some interest, of course, in passes over North Korea, for example. But this is another opportunity where you could uplink, where the user will be able to uplink tasking, execute a collection, and then downlink the imagery even before the satellite goes over the horizon. Okay, this is a slide that shows something about the performance of the satellite. It's actually quite large. It's about 300 kilograms. It has a 5-meter dish. It's flying at about 450 kilometers in altitude. It has 500 watts of RF power for transmitted X-band. So we have a very high resolution performance model that allows us to predict the performance. And so in this particular case, the satellite's flying over the Korean Peninsula, and you can see it looking out of the left-hand side of the satellite as it flies up across the top of the page, up through the top of the page. That the shaded area is the area of regard for the sensor. So anywhere inside that shaded area, which includes the entire peninsula, we can get a 1-meter resolution image. And if you look at the chart down the bottom right corner, that shows for a 1-year period, 365 days, that the average or the median is about 5 opportunities per day to image the port of Kaesong in North Korea at this is inclined orbit, 45-degree inclined orbit. So it's even for one satellite, it's quite good access for many locations around the globe. Of course, we can't see above about 60-degree or below 60 because of the inclination of the orbit. Now we're not going to be satisfied with one satellite. We hope after the successful launch of our first and the adoption, the full use of that satellite, that we'll launch 6 more 2 years later. The first satellite is planned for launch in 2022, with the next 6 in 24, and then thereafter, if there's demand, we intend to launch 12 a year until we get to a constellation of 48. And you can see as the opportunities, the revisit times per day go up almost linearly with the number, with each doubling of the satellites, double the number of opportunities. Okay, and this just shows the orbits. So our current focus, of course, is the design and building of this satellite. We have as I said before, a complete transceiver that's already flown. So our technology readiness level is quite good. We have a design, and you can see the finite element model of the entire satellite there with the 5-meter dish. It's actually a dual band feed with X and L band feeds. One X is Cassegrain fed, and the L is direct fed through a dichroic subreflector, which is transparent at L. You can see there's large solar panels because we need lots of power. And again, it's not really a small satellite at 300 kilograms. So there are 4 key factors that we had to optimize, balance, if you will, in the design of a SAR satellite. The first one is power. You have to have enough power to collect the number of images that you want to collect. In our case, we need about 800 watts of orbital average power to do a 25% duty cycle on orbit. We have the thermal radiators necessary to remove waste heat from the SAR power amplifier to keep it below its operating temperature. We have large reaction wheels to give the satellite enough agility to be able to steer from one target to the next as we pass by. And then, of course, the payload itself, the 5-meter dish and the high-performance transceiver, which has 800 megahertz of instantaneous bandwidth and a completely programmable PRF and pulse width, pulse type transceiver, allows us to optimize the performance of that system for each different image, whether it's taken off the 90 degrees directly off the beam of the satellite's transmit, or squinting 45 degrees ahead or behind the satellite. And so, as you can see in the next to the last bullet here, we expect to have about 23 minutes of active SAR image collection time per orbit. Considering that it takes about 3 to 6 seconds to get a SAR image of 1 meter resolution at this altitude, that's over 200 images in capacity per orbit. And I've always said from the beginning, if we can't drive the cost down, then we don't have a business. So we expect to be able to produce the first flight unit for about 25 million and put her on orbit including the ground system and so forth, for a total of about $37 million total. Our production units later on, as we go to the constellation, will be about $10 million per copy. So this is a quick summary. If you cut that capacity in half, or to about 120 images per orbit, we'd be able to collect them at 16 orbits a day, 365 days a year for a 4-year life. Then we can collect quite a bit of imagery. And if you divide the cost of that on-orbit cost plus the operations of the satellite for 4 years, the cost of that 1 meter resolution imagery is about $1.41 per square kilometer, which means we can sell that imagery for $10 a square kilometer, make a great profit and support the growth of the company, and still be more than 10 times less than a comparable TerraSAR X image, which goes at about $134 a square kilometer. This just shows a quick diagram of our ground system. We intend to use the leased ground stations. We already have a collection scheduler and a collection planner built that we're very happy with one of our partners. And we expect to take orders from directly from customers over the web, and also from information product providers like Ursa, Orbital Insight, Space No. There are a bunch of companies that are doing data analytics and will be extracting informations and creating information products as our partners. The ground processing will be done on AWS, Amazon Web Services. We've already got a prototype of this working with our airborne system, which I'm going to talk about next, where we take the airborne data, link it directly to the web, and it's an automated system to produce the imagery, and we do a little QA, human QA on the backside before we send it out. Here's a picture of the airborne system that we're using. It's the transceiver in black with a bunch of sort of COTS and other pieces put together to create the entire system which is essentially a Pelican case. No bigger than the size of a carry-on piece of luggage. And with a small radar and a camera, we're able to take both airborne, so at airborne systems, to take both EO, electro-optic images, and SAR images at the same time from the same vantage point, which is really, you can see in this example, it's very helpful when you have the SAR imagery combined with the EO. The EO images allows the analyst to inform the identification of various targets of interest in the SAR images, which may not be readily apparent to a non-SAR analyst. So our goal here is to collect a large volume of airborne images for all kinds of targets, potential targets, and then provide those to our prospective partners to start building machine learning models, training these models, and using other analytic techniques like change detection for coherent change detection and non-coherent change detection to do different types of analytics before the satellite goes on orbit. We're going to fly the aircraft in grazing angles and resolutions and image quality that's very similar to the satellite, so that we can we hope to be able to use that to get ahead before the satellite's on orbit in developing these algorithms. This shows our flight, our airborne system has started. We started collecting in June, and we've had a very successful campaign so far. We've collected hundreds of images, and they're currently being organized into a repository for our partners to use. And we plan to conduct at least 1 week of flight campaigns per month over the next 2 years before we launch the first satellite. Here's some more examples. This is a aircraft boneyard, a famous aircraft boneyard out in the Midwest United States, where there's lots and lots of planes sitting in the desert. And you can see the optical and SAR image comparisons here. This is another airport that has helicopters in the upper right left-hand corner of the image. This is a power plant with all different kinds of buildings and equipment in the field of view. Here's an interesting one. This is a set of tents on a tarmac, and the tents are actually transparent to the X-band SAR. You can see the structure of the tent, but if you look carefully at the images, you can tell which ones have planes in them and which ones don't. So here's, of course, a very interesting application of SAR for reconnaissance type applications. Finally, here's another.
5 minutes.
Thank you. Here's another image, and this view graph is intended just to reflect our goal of creating machine learning training data sets for different types of targets, so that we can begin training some of these neural networks to detect objects in SAR images. So bottom line, we're really interested in our relationship with Australia. We'd like to find a way to like you have here, you have government and industry together in this forum. We think that's a great way to start, and we'd like to find a way to cooperate with you as a group. Our collaboration agreements that we're currently pushing and have actually executed allow access through our Amazon Web Services site to the entire repository of imagery. We worked with our partners to collect specific data that they're interested in, and if necessary, we can even bring the aircraft, across the globe and collect locally. We expect to be able to together with our partners, create some of these products again ahead of the launch of the spacecraft, so that we can be ready when the small sats are on orbit to take advantage of them. And finally, here's some contact information for us. That's me on the left, Nick Carangelin. Eddie Cato is our VP for International and is leading the charge on our relationships outside the U.S. We are providing sample data in these formats: GeoTIFF, SICID, and CPHD. These are sort of standard formats in the U.S. government's use of, and really across the board, becoming standards for using SAR imagery. And with that, if there's, I think we just have a few minutes left. If there's any questions, I'd be glad to answer them. Otherwise, we'll be glad to follow up via email. Eddie, is there anything you want to add?
No, I think I'm okay. I guess it's a good time to take a questions. I think
Yes.
in fact, got a couple of questions in the chats, but
Yes, I thank you very much. That has been really a very interesting presentation. I would get the first one that I go through the chat. It relates to soil moisture. So Michael is asking whether a 1 meter SAR product will be soil moisture.
The soil moisture is a combination of L-band and X-band is probably the best way to get soil moisture. You probably don't need 1 meter resolution to get that. We can do up to 10 meter, 5 meter, 10 meters. So I think we would want to optimize the size of the image, the resolution, and the frequency. Maybe even using we have a X and V pulse, so we could do full polarimetric SAR, and X-band might also be a way to do a better soil measurement. So that the interesting thing there, I think, would be to fly the airborne system at X-band and collect some data where the soil moisture is known, so that we can begin to think about how we would use that from space. So that's a great application. We'd love to work with you on that.
Perfect, thank you. Another question goes with processing levels. So what levels of processing will the products be accessible in? Whether, for instance, normalized backscatter, will mosaics be available, or is that up to the customers?
Yeah, the customers will be specifying locations that they want to collect. The airborne system, we can certainly collect different types of imagery. When it comes to the space system, though, you'll be able to order an image of any place on Earth that we can reach. So again, pretty much between 60 north and 60 south latitude, we'll be able to get a 1 meter resolution image at least once or twice a day. Does that answer the question?
Yes, I think it does. Otherwise, you've left all your details and we can get back to you. Michael Chang is asking whether you're considering different wavelengths in the future too, like X, CS, and L. Yes. And what would be, and another one, what would be the interferometric capabilities?
So interferometric, we should be able to do support interferometric at X-band without too much trouble. It's really all about what's your requirement for a repeat pass. You know, if it's within a kilometer, we can probably do that. If you want it, if the passes have to be closer than a kilometer each, then I think that's harder. The repeat pass cycle will be probably long because we're inclined. We haven't really done a detailed analysis of that, but I would imagine that 30 to 45 days we should be able to get repeat passes for interferometric. Now you could also fly them in tandem. Again, there's just like Tandem X does if you wanted to do measurements of height. And regarding other frequencies, we're very excited about potential future antennas that we've seen, flat panel antennas that do multi-band. We think these are really too early right now to put them on orbit, but I think by the time we're ready to put a constellation up in 24, we may have a whole new antenna, and that antenna would allow us to do many bands, and we'll be limited only by the regulatory limits. Just like at L-band today, we can only get about 130 megahertz of instantaneous bandwidth at L-band from space before that's all the frequency band that's available for imaging.
Perfect, Nick. I will close it up here for the sake of keeping the tight agenda we have today. I will have also some more questions. So what I propose is I'm going to collate, there are more questions in the chat. I will collate them and email them to you and Eddie, and then if Joe or Larissa will just share with the rest of the community. I think we have some more questions. Mine was about agreements, but if you wouldn't mind to respond them in written, then we can share to the rest of the community.
Thank you. We welcome your questions, and we look forward to working with you.
Perfect. Thank you very much, and I'm glad the technology did work for us all. If you are more than welcome to stay for the remaining of the meeting that is going to conclude at 12:30.
Thank you very much.
You're welcome. Okay, so I guess, Andrea and all the others, I'm keeping all of the questions, but I need to, how do I do now? Joe, can you help me to unshare the question?
Yeah, I'll just ask Nick to unshare, to stop sharing his screen, and then we'll switch to yours, Graciela.
Okay.
There we go.
Yeah.
Did that work?
Yeah.
Yep.
Okay.
Thanks, Nick.
Thank you.
Okay, so I have to share this one. Okay. Good.
Thank you. That's great.
So next on the item for today is Joe Andrews with a bit of an update on the Geo Week 2019. Joe, if you are there, then I mute and put my video off so that you can take on. Joe Andrews. Is there anyone else that could provide this item on the agenda, or shall I move to Stuart, and then if Joe is around, we move the item for later on.
Hi, it's Joe Andrews here. I just managed to unmute my phone.
Okay, hi Joe, please go ahead.
Yes, thanks for that. Apologies, I'm just on the phone here, so no presentation, but I would encourage people to look at the website for GeoWeek 2019, which can be found under earthobservations.org/GeoWeek19. So just for some context and background on GEO, for people who may not be aware, GEO is an intergovernmental organisation with 105 member countries, but also 127 participating organisations. It's really focused on improving the access, availability and use of Earth observations, and its priority engagement areas are the Sustainable Development Goals, the Paris Agreement, and the Sendai Framework on Disaster Risk Reduction. So GeoWeek is when the Geo Plenary comes together to talk through the work of the year. What will be very exciting about GeoWeek in Canberra, which it will also include a ministerial summit, which is a great opportunity to highlight what we're doing and get a little bit more bandwidth at the political level. And just, sorry, I should mention GeoWeek will be going from the 4th to the 9th of November, and will be located in Canberra at the National Convention Centre. Just give me 1 second here. So yeah, talking about the structure of the GeoWeek, we have the Geo Plenary, which is a closed meeting to Geo members. We'll also have the Ministerial Summit on the Friday. We have also just confirmed the side events that are taking place in GeoWeek, and these will take place on the Monday and Tuesday. There are quite a number of events taking place, so I'd really encourage you to go to the website and click on the side events button, and you can see the different activities that will be taking place. And we also have the industry track, which is my responsibility within the Geo Task Force in Geoscience Australia. The purpose behind the industry track is the recognition of the role that commercial activity plays in providing Earth observations now, and really seeing that this is the way forward, that the commercial sector will provide a lot of the solutions we need going forward, and we really need to start engaging better with them in Geo's activities. And also, having the industry track within GeoWeek provides the opportunity for people who aren't Geo members to still attend the week and network and engage with people in the Geo community. Just wanting to keep this short, I'll focus on the opportunities for people within Earth Observation Australia who may want to get involved. The first thing I'd say is register for the industry track. It's very competitively priced as $250 for the week, which compares very well with any other conference available. I would encourage you to register early. We already are getting quite a good response, and probably for my planning purposes, it's better to have people registering early than the week before. I'll also note we're going to have a very active exhibition within GeoWeek, and it's filling up fast. I think I'm probably at the 80% fill level, so if you have an organisation that wants to show what it's doing to a global community, this is a great opportunity, as well as sort of the government booths. We're getting very strong interest from the corporate end of town, Planet, Amazon and Google are some of the companies that we're talking to at the moment. So I think it will be quite a dynamic area. We're trying to make the exhibition a collaboration zone, so making it easy for people to find a place to do some work and network with others. So hopefully it will be the hub of GeoWeek. And finally, I'd note we have the EO industry platform that's running in parallel to the program for GeoWeek, the industry track. And this is an opportunity for people to provide presentations on topics of issues or of their interest. So if people are interested in doing a presentation at GeoWeek, I'd encourage them to get to the website, look under program under the industry track and the EO industry platforms there. You'll also find under that tab the program for the industry track, which we're splitting it into a range of different areas. One will be a leadership dialogue between industry and the Geo community. We've also got Frontier SI, which is one of our key partners, running an end user forum to do a problem pitch and panels on how to provide solutions. We have CSRO working with us on EO 2.0 forum, which will be really good just to see what's at the cutting edge. And we're working with SEBA on a town hall discussion, a great opportunity to really have a voice and share the issues or opportunities that are coming up in the global EO sector and have that voice being heard within GeoWeek, which I think is very important. As you can guess, I could probably go on forever talking about the opportunities within GeoWeek, but I might leave it there and provide an opportunity for anyone who's got any questions regarding GeoWeek.
Okay, thank you very much for giving us this briefing, and I guess we can all follow the latest developments through the website that you indicated to us. And I will take only one question because otherwise we will be running late. So if there is any question for Joe at this stage, otherwise I will like to thank you, Joe, for reminding us on the early registration and to keep an eye on the event, which is important for us as scientists and also for the community. Well, no
Great.
question.
Thanks, Graciela.
Thank you very much. And then I would like to now pass on to Stuart for the debriefing or our latest news on NCREASE. Thank you, Joe, and welcome, Stuart.
Thanks, Graciela. Can you hear me all right? Okay, good. Can you just go to the next slide, please? Okay, so this will be quite quick. At the moment, there's no formal update on what's happening with NCREASE funding, specifically around Earth observation. The major facilities, so IMOS, TERN and AuScope, do still retain some Earth observation capabilities. Within TERN, we're likely to see that decrease over time. Within IMOS, there's a range of activities kicking off around satellite altimetry, sea surface altimetry, and working groups there. If people are interested in getting engaged, particularly across the ocean coordination space with Earth observation research infrastructure, there is the Operational Oceanography Forum at the end of this year, which I'll post a link to the chat in a minute, and that's a good indication, it's a good event to get along to hear what's happening in the field and with imagery in terms of IMOS-related activities. There is an Australian calibration validation program, which is likely to be launched soon from CSIRO, Geoscience Australia, the Space Agency, and Earth Observation Australia. So we'll hear some news about that soon, and that builds on the NCREASE bid that a number of you helped us put together previously. So hopefully we'll see some news about that soon. The last item is to do with the picture that's on the screen that you can all see in front of you at the moment. The question is, what does that have to do with infrastructure? If we look at Earth observation in Australia, we've got a lot of activities in research. We turn research into applications and get it working nationally, and that's what our NCREASE capability or our research infrastructure helps with. Ideally, once it gets out of research infrastructure, it should transition into operational activities within government and industry at Commonwealth and state levels and private industry. We haven't had a good way of doing that at the moment. The Earth Observation for Government Network held its first major national coordination meeting last week. So the people in the photo are leads from state and territory agencies all across Australia involved in Earth observation, and a number of Commonwealth agencies that produce and use Earth observation. And this meeting was about how do we transition sort of from research proven through to state government activities and Commonwealth activities, particularly in Digital Earth Australia. So we will have a summary report on that network, and it's the database it's set up and recommendations for going forward in the future. So I'll leave it there, Graciela, and take questions later on.
Excellent. Thank you very much, Stuart, and thank you for keeping it on time and short. So yeah, we might do a wrap up of questions if needed later on. So I will now invite Lachlan McKenna from the Australian Ocean Optics Conference bid to give us a very brief update on the conference bid status.
Shall I share my screen here? Is that easier?
Joe, can you help with the sharing of the screen?
Sure. Graciela, if you could just unshare your screen, please. And Lachlan, if you can scroll to the bottom of the screen.
Okay.
Oh, hang on. Okay, sorry.
Gotcha.
Lachlan, are you there?
Yep.
Okay, can you share your screen now? Great.
Can you see that now?
Can see that? Fantastic.
Okay, great. So I'd just like to thank you all for giving me a chance to talk about an exciting opportunity for bringing a conference to Australia in 2022. First, I'll just introduce myself. For those of you who don't know me, my name's Lachlan McKinnon, and I'm a satellite oceanographer and bio-optical algorithm developer. And I've worked for NASA Goddard Space Flight Center's Ocean Ecology Lab and Curtin University's Remote Sensing and Satellite Research Group. I'm a JCU graduate, and I currently run my own scientific consultancy here on the Sunshine Coast called Go to Q, where I continue to work closely with NASA and JAXA. I'm also a adjunct research fellow at James Cook University. So I was recently successfully shortlisted by the Ocean Optics Organising Committee, along with 4 other candidates, to put together a full bid for the 2022 Ocean Optics Conference on the Gold Coast. I'm working on this in collaboration with Destination Gold Coast, but I'm currently seeking support from Australia's leading research institutes to demonstrate that as an Earth observation and oceanographic community, we're really excited to host a conference such as this down under in 2022. And I've been invited today just to tell you a little bit more about the conference and why it would benefit the community to host it here. So, as some of you may know, the Ocean Optics Conference is the premier scientific meeting on hydrologic optical theory and application. And I should note that although we use the term ocean in the naming of the conference, it has really branched out into the coastal and inland water communities as it's developed more recently. The meeting has been running since about 1972, and it's convened by NASA and the Oceanography Society, and typically attracts about 400 plus international delegates for a week-long conference. And if we're successful in winning Ocean Optics 2022, it'll be held sometime in October. Topics that are typically covered during the meeting are optical theory, remote sensing, autonomous underwater and airborne systems, underwater vision, marine biogeochemistry, phytoplankton ecology, shallow water mapping and bathymetry, harmful algal blooms, water quality management and coastal ecosystem management. And I'll note that over the past couple of decades, this meeting has been really integral to the Ocean Color remote sensing community. Typically, there are a range of short courses that are offered at every meeting. And in the past, they've included EU Copernicus training, NASA CEDOS training, Acolyte, Landsat, and Sentinel high-resolution data processing, validation metrics workshops, and Accurate RT, which is a radiative transfer code. Obviously, if we're fortunate enough to host in Australia, we can get local software and tool developers to present their work in short courses as well. Also note that there are a range of industry exhibitors who attend this meeting regularly. In the past, it's attracted some of the exhibitors you'll see on the screen. I won't go through them all, but bringing the conference into our own backyard would be great to allow some of our own developers of instruments, software and tools to exhibit there. Now, previously, the Ocean Optics Conference, it's usually held in North America or Europe every 2 years, with the conference returning to North America every 4 years as the rule. Now, for 2022, the Ocean Optics Organising Committee are interested in taking the meeting elsewhere, and this has only happened once before in its 48-year history. So I've been lucky to get the Gold Coast here in Australia shortlisted as a potential host city for 2022. I'm now working up the full bid. So the city of Gold Coast, for those of you on the line who are
not familiar, focuses on attracting world-class events to its wide range of conference venues and facilities. It's my intention to move forward with a bid to host Ocean Optics 22, most likely at the Gold Coast Convention and Exhibition Centre. It's a state-of-the-art facility that will meet all the needs of the conference, and it's also world-leading sustainable venue and the first convention centre in the world to be Earth Platinum certified.
1 minute, Lachlan.
Okay. So obviously, sorry, and I have 5 minutes or 10 minutes?
5 minutes only.
Oh, okay. Well, I'll skip to the end then. That's sorry.
Yes, please. We will browse the beaches and all the rest.
I beg your pardon?
We will browse the beaches and all
Okay.
the rest later on. Thank you.
Okay. All right. Importantly, we've got a good team here on the ground here in Queensland. It's myself and Jamie Cool at Go to Q and Norma Swain at Destination Gold Coast. And if you guys get a chance to browse later on, you'll see there are a number of really great opportunities for the Earth observation community here in Australia to engage with this conference for mutual benefit. So importantly, I'm seeking your support in order to deliver a really strong bid to the Oceanography Society. And what I'm looking for are letters of support from Australia's research institutions and industry leaders. And I'm not necessarily asking for any financial commitments, rather letters to show the Oceanography Society that there is a really strong Earth observation research community here in Australia, and that the local community recognise that there's great mutual benefit for hosting this meeting. Obviously, in principle, financial commitments would certainly strengthen the bid. And Jamie and I Go to Q are available to assist you in preparing a letter of support, so please get in contact. And with your support, we look forward to welcoming delegates to the Gold Coast for Ocean Optics 2022.
Great, thank you very much, Lachlan. I guess the more important thing for you would be the deadline for the letters of support. So if organizations and individuals would be willing to give a support to this one, what would be the deadlines for those letters?
Absolutely. So the deadline for our bid, we've been given a very short window to develop it, is October 15th of this year. The bids are due. So if we could have letters of support by the end of the first week in October, that would be great. I know that Earth Observation Australia had suggested that they would allow us to send out an email to the group potentially with these details, what we're looking for.
Perfect. That's excellent. Okay. Oh, thank you, Lachlan, very much, and thank you for accommodating from 10 to 5. That has been really a great ability. So thank you very much. And I guess all the details are in your presentation. The meeting of today is being recorded, so people can go back and check again on your spot. Thank you. So Lachlan, if you can share your screen, so we go back to the next speaker. Sylvia Michael. Sylvia is with the steering committee of the Earth Observation Australia, and Sylvia will give us a brief overview, a brief update on the plans of the steering committee. So Sylvia, I'm trying to share the screen. Yeah.
Thanks, Graciela. Can you hear me?
Yes, we can.
Great, thank you. Good morning, everyone. I'm Sylvia Michael, and I'm the Deputy Chair of Earth Observation Australia. In our last whole of community webinar, Stuart mentioned that we'd begun our transition from an informal group to a more formalised structure, and I'm very happy to report that the first stage in that process has been completed, and we are now Earth Observation Australia Inc. And we are an incorporated body in Queensland, and thanks very much to the great effort of Joe Edkins. Hopefully all members would have seen the email advising you of this. So I just wanted to remind you that the couple of points from that email, and also as Stuart mentioned at the last meeting, that the current steering committee have been renamed to the Management Committee as part of the incorporation process, and that there is a formal constitution and a code of conduct which is available from our website. Acceptance of this constitution is a condition for all memberships, new and ongoing. So the next step for EOA Inc. is to become a registered Australian body so that we can operate in all states and territories. We are in the process of doing that now, and we'll let you know as soon as this process is complete. Once this next stage is complete, we will apply for an ABN and open a bank account in our own name, and we will address our insurance requirements. We will also then revitalise engagement with our working groups in line with our 10-year plan. Stuart also mentioned at the last meeting that there'll be an increase in staffing resources through UQ, and you would have already come across or heard from Larissa Marfan, who commenced in May as Earth Observation Partnerships Coordinator. And in July, we welcomed Karen Malloy as Science Communications and Coordination. Larissa and Karen will also jointly be coordinating the meetings of the Management Committee and the whole of community from now on. It's a very brief resume of the status of the current Management Committee of Earth Observation Inc. And I don't really have anything else to add to that, but we will certainly be keeping you abreast of the transition to a formal status. So thanks, Graciela. That's all I've really got for the moment.
Okay, perfect. Thank you very much, Sylvia. Is there any question from our participants? Please write it in the chat box that we have. Otherwise, I will just proceed to the next presentation. That my thing decided to stop working. So our next, we have one update more, which is from Renee Bartolo for the Earth Observation Forum 2020. Renee, are you?
Yeah, hi, can you guys hear me?
Yes, perfectly.
Awesome. Cool. Thanks, Graciela. So I think we've got some slides, Joe. Are they coming through? Maybe. Yep. So the first important thing we want to say is save the date. Make sure that you keep 28th of September to the 1st of October 2023. The Earth Observation Forum will be held in Brisbane, inviting everybody. So pass the message on wide and far. And we are also looking for workshop ideas and supporters and sponsors. So get in contact with us if you've got any ideas for workshops. Most importantly, I think if we can go to the next slide. Thanks, Joe. Most importantly is this is not going to be your typical conference. It will still enable all the communication and you know, you'll hear some technical content, but we're trying to have it more interactive and more collaborative, a lot more opportunities for people to talk about things and resolve issues that affect Earth observation. And just some sort of mechanical updates about what's been going on with the actual forum committee. We've got a couple of subcommittees that have been meeting, the program subcommittee and the sponsorship subcommittee. We've chosen the event organiser and the processes are starting with that, and an application for seed funding was submitted to the Queensland Government. So it's all on track and full steam ahead. So yeah, please get in contact with us if you would like to contribute some ideas for workshops or any other content. Thank you.
Perfect, Renee, thank you for keeping it in really on time. That was fantastic. Good. So we go to the last section of this webinar, which is the interactive session. And for today, we have invited Adrian Fisher to give us a 15-minute presentation, and also two panelists, Dr. Marta Gebra and Arco Lucier. For those that don't know Adrian, he's a research fellow with the Joint Remote Sensing Research Program at the University of Queensland. Adrian conducts research into large area mapping of vegetation structure using satellite and airborne data, and he's also interested in using Earth observation data to examine the geomorphic evolution of Australia's desert. I will take also the time to introduce briefly the two panelists. Martha Jeffrey is a senior researcher at ANU, and she has a background in remote sensing of vegetation biophysical properties. Martha leads the development of the Australian flammability monitoring system that provides information about fuel, moisture content, and landscape flammability for Australia at near real time. Associate Professor Arco Lucier is Associate Professor in Remote Sensing at the University of Tasmania. Arco leads the Terra Luma research group that focus on the development and application of unmanned aircraft systems, sensor integration, and image processing techniques for environmental, agricultural, and high precision aerial mapping applications. So for today, we have invited Adrian to give us a presentation on mapping vegetation structure with Earth observation data. So Adrian, I'm all ready. I will mute my microphone and video, and you tell me how to advance the slides.
Hear me okay? No, you can't hear me?
Oh, you're a little faint. Can you just can you turn your volume up a little bit?
Okay, I'll try.
Oh, that's better.
That's
Thank
better?
you. Yeah,
Okay.
heaps better, thanks.
Cool. Okay. Yeah, I should just mention that although I'm a research fellow at the University of Queensland in Brisbane, I actually work in Sydney as a visiting fellow at the University of New South Wales. So I'm 3 doors down from Graciela, but we've got our door shut and we're online because that's the way we work. I also work closely with several scientists in the New South Wales Office of Environment and Heritage, or OEH. They're a partner in the joint program, and I work quite closely with them to operationalize a lot of the work that I do and to work on their high performance computer and use the data archive that they have. I work with heaps of different people across this big collaborative group, and lots of people you might have heard of, like Peter Scarth, and most of the work that I'll present will be the results of collaborative work. So it's not all my stuff, it's work with lots of other people too. Can you go to the first slide? Thanks, Graciela. So just a little introduction to what the Joint Remote Sensing Research Program is. The website's there, and there's a little description there. It was set up in 2007 to increase the research capacity of the Queensland government, and has since expanded to cover other state government agencies and universities. And it focuses on developing strong research collaborations that share knowledge, mainly about large area satellite remote sensing for environmental monitoring. The joint program's website has a list of all the publications that have been written. So if you're interested in any of the papers or research that I refer to, you can find them all listed there. And then on the other side of that slide, there's a table of data products that you can get through the TURN website. And a lot of these, you'll notice, have got the Joint Remote Sensing Research Program against them, or it says Joint Program Algorithm and things like that. So a lot of the things that we produce, we release through TURN and to make them accessible to everyone. So we're trying to share as much as we can. Some of these things, there's a couple of pictures there. There's a surface reflectance algorithm that we use across Landsat data, and the fractional cover algorithm that comes from that, where we unmix the Landsat pixels into bare ground, photosynthetic vegetation, and non-photosynthetic vegetation. And they're both available as time series products, which are extremely useful for various applications, particularly in vegetation work like that I'm working on. And then I've also listed a couple of different examples of software that we've developed in the joint program. We tend to work with open source software, mainly using Python and the GDAL open source packages. And if you're interested in using some of this, there's something that's been released called RIOS, which stands for Raster Input-Output Simplification, which allows us to do spatial processing. And then we've also developed, or the joint program has heavily helped the development of PyLidar, which is same sort of processing software, but for LiDAR point clouds rather than just raster data. The next slide, Graciela. And then my research doesn't only use a lot of that Earth observation data that you can look at through TERN, but it also uses a lot of field measurements of vegetation structure. And if you look on the TERN field data portal, you can see, which is listed there, you can see that there's something called the star transect site measurements, and they've been collected all across Australia. And this is where we lay out 3 100-meter tape measures in a star shape, and then vegetation structure is measured at 1-meter intervals along each tape. And this gives 300-point intercept measurements across a hectare site. And those 300 measurements can be combined to give site measurements of lots of different structural variables, which I've listed some of them there. We can calculate fractional cover, and that's what Peter uses as the basis of the algorithm. But we can also calculate tree metrics of foliage projective cover, or the area covered by leaves in the tree canopy, or crown projective cover, which is the area covered by the tree crowns. We also measure in these sites basal area using an optical prism wedge and the angle count method, and that gives us an estimate of the size and number of tree stems within a site, which is related to biomass. And as you can see, there's several thousand of these star transect site measurements are now available across Australia. The Northern Territory government has been involved in a lot of collaborative work recently, which is why there's a huge number of green stars there across the Northern Territory. So now I'll go into some examples of my research that has used Earth observation data and these star transect field measurements in terms of how mapping vegetation structure. The next slide, thanks. The first example I'll give is some research I did into using drone imagery, and whether or not that could be used to measure fractional cover in the field. New drone technology really has the potential to collect data quickly over large field sites at very high spatial resolution. And so we organised a workshop at the Fowler's Gap Arid Zone Research Station, mainly organised by Richard Lucas and Arco Lucia. And they brought together lots of different researchers using drones with different instruments. And we collected an awful lot of data. The next slide, please, Joseph. So one of the instruments that was flying quite a bit was a 4-band multispectral sensor called the Parrot Sequoia. And we were really hoping that this sensor, because it measured in the red edge and near infrared spectrum, would be excellent at getting vegetation structure and fractional cover from these arid zone shrublands and grasslands that we were acquiring the data over. So with a field team, I measured 20 star transects across the field station, and the different UAV groups went out and flew different areas, and we were able to collect quite a lot of data. This data has been made available through TERN as well. So if other people are interested in looking at some of this Parrot Sequoia data, where we have field measurements of things, there's it's all available. The next one, thanks. And then working with Arco at the University of Tasmania and a postdoc of his, Bethany Melville, we tried a few different ways of getting fractional cover out of these drone images. We used a downscaling model where we used coincident Landsat data. And the second method, we used a spectral unmixing method, which is the same as is used on the Landsat data. And we also used the object-based classification method. And there's On the left there, there's one site example where there's a tree close to the center of the star, and the three different ways of getting fractional cover out of that imagery. And on the right, there's the results where we've got the three different fractions of cover, and we've got the field measurement on the x-axis and the UAV data on the y-axis. And we were a little disappointed in the ability of these methods to capture the fractional cover, and the different methods were able to get the photosynthetic vegetation quite well. So the red edge and near-infrared bands were very helpful at getting the green leaves, but separating the dead leaves and litter from the bare ground, getting those fractions out was quite difficult. The classification with objects worked the best at the star transit scale, but all of them really were unable to do things at the really high resolution of the UAVs. But it was interesting research to do because there's been a lot of speculation around the growth of drone imagery and how it can be used. The next one, please. So the second example I'll give of the research that I've been doing is of mapping tree cover and foliage projective cover in particular. And this work is really the bread and butter of the Joint Remote Sensing Research Program, as the state government agencies that are partners in that program really are required to monitor tree cover, and mainly for detecting tree clearing. So a lot of effort's gone into doing this work. On the left there is the first set of models that were developed using Landsat data back in 2009. And this was really done when the joint program was quite new, and it was work just done across Queensland, and the model was developed to relate the foliage projective cover measured on the ground to Landsat pixels, and it did a pretty good job. Then later on, the New South Wales government had the need to go to a higher resolution than Landsat data, and so they started purchasing a lot of Spot 5 satellite imagery, and that enabled us to take the Landsat model and use it to calibrate a 5-meter model using the Spot 5 data. And both the Landsat and Spot 5 models tended to overestimate the FPC or tree cover where green ground cover occurs. So it's very hard to separate out some of that ground cover from tree cover using the satellite imagery. So we developed some multi-temporal analysis where we could use areas that have had persistent green cover to predict they're more likely to be trees than ground cover, which fluctuates. And that produced a 5-meter map of tree cover and FPC for New South Wales, which is available through the OEH and Turn websites. And then we could see in that map that we'd made that there were still a lot of errors, and a lot of them were manually edited out. So we ended up using some 50-centimeter aerial data that had been captured over much of New South Wales to try to make some improvements. And the figure on the right there is just showing some of that 50-centimeter data and how we were able to use a fairly simple thresholding technique to capture the trees in that data and use that to update the 5-meter spot map. Next slide, thanks. So the Joint Remote Sensing Research Program tree maps have tended to focus on
3 minutes, Adam.
Thanks. Foliage projective cover, but foliage projective cover is not used that commonly around the world. So we've looked into how it relates to other measures of tree cover, such as crown cover being the main one. It's used in the definition of forest in lots of places. So this is just an example of some work that I did looking at the theoretical relationship between FPC and CPC, and bringing in some other variables such as alpha, the proportion of wood in the canopy. And we're able to actually come up with a fairly successful way of converting between some of these different canopy measurements. Next slide, thanks, Rocio. So that work really got me into thinking that we could model some of these things from airborne LiDAR data. So I collated all the sites where airborne LiDAR had been flown over star transects, a lot of them in Queensland, and they cover quite a good range of vegetation types with different crown covers and heights. And then I have been comparing different LiDAR metrics of canopy cover with these field measurements, and the graphs down the bottom there show some of those comparisons. And we're able to model some of these things from airborne LiDAR data with an error of about 6-7%. And this work's in review at the moment, but it's we're hopeful that'll get through soon. Next slide, thanks. And then that work has led me on to how basal area can be brought into these equations, and how does basal area relate to FPC. So I've been looking at these coincident field measurements of FPC and basal area, and then modeling these things. This is current work that we're doing at the moment. And the graphs there on the right show that live basal area and foliage projective cover are quite highly correlated. So we can predict one from the other. Next slide, thanks, Grayson. And that's really got me thinking about modeling basal area from airborne LiDAR data. So the sort of airborne LiDAR data that we have available isn't very high pulse density, and you can't really detect the tree trunks in the dust. We can't measure basal area directly, but because there is this close relationship between different metrics, we're hoping we can get them out of the basal area out of the airborne LiDAR. And the last slide, thanks, Grayson. So that leads us really into this a project that's still ongoing. It's being done by Anthea Mitchell with some consulting work by Mark Williams, where New South Wales has got and processed a lot of ALOS pulsar and ALOS 2 pulsar 2 scenes from across the state, and done a lot of pre-processing to normalize this data and remove the effects of soil moisture from the different swaths. And we are, because this polarized HV data is it's about 12.5 meters resolution, because it has quite a strong association to biomass of the trees, the L-band signal. We're hoping to relate this radar data to the basal area site measurements, and build some models of basal area so that we can look at change and then look at regrowth in the forests across New South Wales. So that's the end of the talk. I hope you have got a feeling for what I do and what the Joint Remote Sensing Research Program does. And thank you very much.
Thank you very much, Adrian, to keep on time, and it has been a very interesting, I guess, presentation in terms of what is operational, what the community can access through the prior work you did in turn and your current research. So I would have one question for you, and then I would like to move to introduce Arco and Marta, so that we have more of an overall discussion in terms of this work that you introduced. So we have my first question to you is whether do you have any plans to do more of these UAV or ground-based measurements to complement the star transects that you spoke about?
We do the UAV data, I should say. Yeah, that does seem to be a lot of potential in that. perhaps that we didn't explore fully in the work at Fowler's Gap, especially using vegetation height that can be gotten out of UAV data using the photogrammetric structure from motion sort of thing. So I think that's an area that would be interesting to look at. But I think the main focus with our work in the joint program will go to comparing the star transect measurements with terrestrial laser scanning. So there's been some advances in the speed of terrestrial laser scanners and the ability to collect that sort of high pulse density field data. So I think that's where our field work will be going.
Thank you, Adrian. May I now introduce Arco? Arco, can you unmute yourself, and Martha?
Yeah, can you hear me?
Yes, perfect. Thank you very much. Welcome,
Right.
Arco.
Thank you.
Martha? Remember to unmute yourself. Well, I will start with Arco because I guess it's a good link on in terms of your research interest, following up from Adrian's presentation and what he described in prior work in the Fowler's Gap. So can you, Arco, tell us about the current UAS or UAV drone activities within the TERN landscape programs, and also what other sensors and mapping techniques are considered to be operational at this stage, and what do you think are techniques that are still experimental?
Yeah, great. Thank you. Yeah, so Adrian's presentation covered some of the data we collected quite a few years ago now, and there's has been quite rapid development in sensors and sensor technology. So one of the things we are exploring in TERN, the Terrestrial Ecosystem Research Network, in the Landscapes project, is the use of sort of relatively simple and low cost drone technology. So think about the typical DJI Phantom quadcopters with RGB cameras and a 5-band multispectral sensor. So we're basically documenting data collection protocols that allow us to collect data consistently, so it can be used across the country by different teams, and it can be used to really quantify change. So the typical products that we're proposing that people will generate are RGB orthomosaics at a resolution of a centimeter or so, over an area of around 4 hectares, multispectral orthomosaics, and 3D point clouds derived from structure from motion. So many teams are working or collecting this type of data, but the main difference we're trying to make is to come up with solid protocols for field data collection. So think about flight planning, flying height, overlap between flight strips, the angle of the camera settings, like exposure time and so on. All of these things are really important when it comes to deriving data consistently. Another aspect is metadata. So what type of metadata should people collect? Then how should it be uploaded? What sort of processing levels, the file naming, where should it be uploaded? So this is all part, and really important part of UAS data collection that we'll be working on within TERN. So I think that type of data collection with RGB multispectral data has become quite common, and that's certainly operational. I think where we're moving more into the research space still is the use of high-level sensors such as hyperspectral and LiDAR sensors. Having said that, LiDAR is also getting more and more common, and there's several turnkey solutions out there now. But within the TERN network, we're also aiming to visit one of the super sites each year and then collect LiDAR and hyperspectral data over those sites. And I'll just pause there, Graciela.
Wonderful. Thank you, Arco, for this update. Is there any question from the audience, our participants? Arco, if I know you have to go to 25, so perhaps one question more is about the data sets that you were describing and the protocol that you are preparing. So when do you envisage that these guidelines you described before would be ready to share with the community, and where the community could find that protocol?
So the protocols are currently in the final draft stage, and we expect to release them in October to the Turn network, and that will become available on the Turn website and on the Turn wiki. But certainly before the end of the year, that should be finalized. We also aim to publish a chapter in the field handbook early next year.
Excellent. Thank you very much, Arco. Because we have about 7 minutes left, if I don't see any questions for you, Arco, I will move to ask some questions to Marta, and then we could come back if time permits. So Marta, can you hear us now? Seems that something is not working with Marta's. Or at least your video, Marta. Joe, might you be able to unmute Marta from your end?
Hi. Yeah, she is unmuted. I think there must be a problem on Marta's end with her mic. Marta, are you there?
Yeah, because I can't even see any.
This is Adrian again. I just would mention sometimes a headset has a mute button on the side of the headset, and that's tricked me before with being doubly muted.
Yeah, Marta says it. She doesn't know why the microphone is not working. Okay. Well, let's Marta, let's give a couple of minutes, and let's try to see if you can make it work. 1 or 2 minutes if we can. Otherwise, we will reschedule you for a panel on the next meeting if that's not possible today. So may I ask, Adrian, in terms of the data sets that you were describing of current research, Adrian, when do you think that these data sets that you just spoke about for New South Wales might be ready and operational, and if this is something then that you think will be applicable in other states?
Yeah, I'm not entirely sure about some of those things. I'm not the LiDAR work that I've been doing would be interesting if we can get some standard LiDAR products out using various algorithms. That would be great to be able to make standard vegetation products available for everyone from airborne LiDAR data, but that will require some infrastructure to. I know Geoscience Australia are housing a lot of airborne LiDAR data for the digital elevation models, and whether or not they could also house vegetation structural information as well would be interesting to find out. The radar data that we've got, I guess, the Pulsar 1 data from 2009, that was all acquired from Geoscience Australia, from their archive. They've got all that data available. The ALOS 2 data, the New South Wales government had to purchase, so I'm not entirely sure licensing agreement that we have with the use of that data, but the final products that we develop, whether that's basal area models or biomass models, they should be able to be released when they're finalized. But yeah, I have to say that the timeline for these sort of things is probably in the order of within the next year or year and a half or something like that.
Perfect. Okay. Well, thank you. Thank you, Arco, if you are still there, and I understand that you needed to go 12:25, but thank you, Adrian, for putting together this interesting presentation on your work, and Arco in just giving us this update on the protocol and further research that you're doing and your thinking in terms of experimental and operational UAVs. So with this one, I'm going to wrap up the meeting. Thanking everybody for your participation today, and don't forget to do the exit survey. The hyperlink is on the screen. Next events are in the website here, and well, thank you everybody for taking part and being another member of this we hope growing community. Next meeting is on Thursday, the 10th of October from 11 to 12:30. And if nothing else, I will close the meeting here. We will collect the questions for Nick, and we'll share, Joe will be in contact with you. Thank you everybody, and have a good day.